All right. We're back with another Infinite Layers. We're currently live here with ARPA Network, and I'm here with the founder who is going to dive into everything about ARPA, and I'm going to learn a lot, and hopefully you'll learn a lot as well. So Felix, would you mind giving us a quick introduction to yourself, and then also a quick TLDR about ARPA, and then we'll just dive right in.
Sounds good. Sure. My name is Felix. I'm the co-founder and CEO at ARPA Network. We have been around for 6.5 years. I started ARPA in early 2018. It was 2 cycles ago, and still grinding. We are making some cool, cryptographic technologies like threshold signature schemes, and we are also researching into zero-knowledge machine learning these days. So we can cover that, in this interview. And I'm very happy to be here.
Awesome. So yeah, I would love to learn a little bit more about your background. So you've been in the blockchain space for almost 7 years. You said over 6 years. What did you do to kind of lead to this point? Did you get into a different form of technology and then kind of make your way into blockchain, or have you always been interested in this space? Yeah, just curious to hear your path.
Of course. Where should I start? Yeah, it's been so long. I have a fantastic core team, and I have 3 other co-founders that we started ARPA together, right? So my background is more on the business side. So I went to New York University for college. I studied information systems and finance. So it's kind of a crossroad of technology and finance. I first got to know crypto actually during college back in 2012. My professor for information technology class actually gave some Bitcoin to each of his students for free. So that was the first time I got to know about Bitcoin. But unfortunately, I lost that laptop. So I don't have that Bitcoin back from 2012. And the next thing I know, and then like after college, I actually worked at a hedge fund as my first job. I was doing some research at a hedge fund in New York. And the traders were talking about it back in 2013, 2014, thought it was a scam. And after that, I actually bought my first Bitcoin back in 2017. Because I got into the technology, and I thought Bitcoin is like really cool. It's not a scam after all these years. And today, Bitcoin surpassed 100K. So it's definitely a big day for the whole industry. And for my co-founder and tech team, actually one of our co-founders and cryptography researcher, he got a PhD from Tsinghua University, the top university in China. And so his research has been focused on threshold signature schemes, lattice cipher, zero knowledge proofs, etc. like during his PhD time. So back in 2018, the 4 of us, we got together and started ARPA. At first, we actually want to solve the privacy problem for blockchain. But later on, at first we were researching into, we were kind of looking into the general purpose multi-party computation. But later on, we found that general purpose MPC is too computational heavy, and also like very communication heavy. It is not possible to have a lot of use cases. So after 2 years, in 2020, we refocused and pivoted into specific algorithms, which is threshold signature schemes, and then we were exploring some use cases using threshold signature schemes since then.
Got it. So how did the ARPA Network company get started in terms of like taking that knowledge and that research and that understanding and wanting to kind of bring it to market to solve a problem? And kind of how did you get from where you were 6 years ago into now from when the company was started?
Of course. Like any startup, we had a lot of hardship. We faced a lot of challenge, especially at the beginning. I remember back in 2018, in April, the market was still kind of hot, right? Because in February, like altcoin peaked in February of 2018. And I started in April. So we were very lucky to raise our first round. I remember clearly we raised 2,000 ETH. Back then, it was about what, like $1 million, $1 million US for our first round. However, we held down to our ETH, and then ETH went down from $500 to $100 each. So we don't have enough money to even pay our salaries. So like financial hardship is definitely one of the difficulties. And also, like, in terms of the use case, because back then we were doing some, like, we tried to pitch banks and also like financial services companies to do this privacy preserving computation. For example, one of the use cases that we actually went after was, like, let's say there are two banks that they want to cross-check if this one person is on any of their blacklist, right? So like we can use multi-party computation to actually cross-check if there's anyone that blacklisted. However, the thing is, back then the banks, they don't really understand the technology, and they don't really trust the technology. It's new, right? It's very innovative. However, the banks are very slow, and then they're skeptical about us like being the middleman. But in fact, we cannot get any data. So that was kind of the biggest problem, that we go after these businesses and they are not crypto native at all.
Okay, got it. And then in terms of like deciding how to come up with the product, bring it to market, get users, like how has that experience been? And with crypto, it's interesting because you have a lot of overlap between often finance as well as like deep technical research, pushing the boundaries of new areas. And then you combine that with almost like infrastructure that developers can use, and you kind of put that together into some type of product. With ARPA, like what would be the main use cases that a developer would want to start, building with ARPA, like let's say today, and then ultimately, where do you see that going? Like, is it a scoped down, list of things that you can do today, and then like where does that, ultimately go?
Mm-hmm. Right. We always try to find new use cases, using threshold signature schemes. And currently, like, we have this product called RandCast that we provide temper-proof, verifiable random numbers. So there are many use cases for verifiable randomness in blockchain, in crypto space. For example, gaming, for example, lottery, and also community tools. So whenever that you actually want to select a winner, in a tamper-proof, verifiable way, we can do that. And then currently we integrated with 7 EVM chains, and we are rapidly expanding our integration with other chains. And so far we have around 10 clients that mostly they are games and also or lottery projects that they use our random number to pick the winner. And then so for the requests, like our most requests are on Base blockchain.
Awesome. So like if someone wants to interact with ARPA, is it essentially them having some type of like off-chain component to interact with the network? So for instance, if I'm in the Base network and I'm writing a smart contract, is it like an asynchronous call where I kind of emit an event and then I pick the event back up? Or is there an SDK, or is there a smart contract that I can import where it's like a synchronous operation? And I'm sorry, if this is a dumb question. I'm just kind of like thinking about, how I would start building.
Sure. Yeah, the developer experience and user journey is like, so essentially like they just request from they just request a random number, and then we provide SDKs that they can, basically integrate RandCast with a couple lines of codes, right? And then we have adapter so basically like the core components of ARPA network is that we have a group of computation nodes that runs the threshold signature schemes. and then they essentially like provide partial. So like basically with one public key, there are partial signatures. There are partial keys in each of the nodes, and then as long as they meet certain threshold, they will do one, essentially, they will do just one signature. And then that one signature contains the randomness. And then we have adapter smart contract on different chains that it can react to the request from the DApps that are requesting these random numbers. So, you can think of us as a verifiable off-chain computation network. And with the help of EigenLayer that we can have, currently we have, I think, hundreds of operators that it can run threshold signature schemes for the ARPA network and react to these random number requests on different blockchains.
Got it. So how challenging is it to add support for additional networks? So Base, that's a smart network to be on. Obviously, there's a lot of activity there, but you also have kind of tons of new rollups and L2s coming out almost like it seems like every week now. If someone wanted to add support for ARPA, or if you wanted to add support for another network, what does it kind of look like? Is that something that you do yourselves? Is it like a big lift, or is it something that someone else could potentially do themselves?
Currently, it's still done by our team. Essentially, like we look at on-chain activities, especially like game activities or lottery activities that we consider which chain to integrate, and then we also talk to our potential clients that which chain they are deploying. So we want to integrate with the chains with like more customers essentially, so the integration process is quite simple. We can integrate any EVM chains within, I would say, less than a week.
Okay, got it. That makes sense. In terms of if I wanted to use ARPA, is there like a payment that needs to happen? Like, what is the model for actually facilitating this activity? Just kind of curious how that would work.
Sure. Yeah, we have this subscription model. So right now it's pay per use, but we are considering to provide some subscriptions package. And then we also have this portal, that you can deposit some ETH or some other cryptocurrencies, and then you can just pay per request, using the RandCast service.
Okay, got it. That makes sense. So if I was using ARPA and I was paying, is that done from within the contract? So I would essentially pay like a transaction fee from the call, or how does that work?
Right. Right. So like for each RandCast request, a random number request, essentially like you as the customer, right, the DApp customer, have to pay the gas fees from our nodes, right, who's submitting the RandCast, who's submitting the signature, the partial signatures, and also this like group leader who submit the combined signatures, and essentially that's the randomness. Like it works kind of like a gas fee. So it subsidizes the nodes and also pay like a little bit extra. But currently, like we don't charge as a network. We actually don't charge any money. All the proceeds goes to our nodes.
Got it. Okay, that makes sense. Okay, cool. So it seems, when you first hear about this use case, it sounds like it's a pretty small amount of breadth of what actually, would be used here. But in reality, this is something that's used all over the place. And there's a lot of activity that requires, essentially a truly unique random number that has not been tampered with. Like, what is the current market that you kind of see for this type of, I would say, API, and what is the current market now, like versus where maybe it would be in the future?
I would say RandCast is just one of our use cases. We are actively exploring some other use cases. right now, we actually we plan to publish some articles about zero knowledge machine learning. I think that is also something very interesting, like the cutting edge of zero knowledge proof and AI. So before RandCast, I would say we try to be the best in terms of security. We try to be the best in terms of developer experience. We try to write a lot of consumer smart contract examples so that people can just integrate with a RandCast with very limited amount of codes, right? So we try to streamline in these fronts. I would say a lot of people we have been around for a very long time. So it really doesn't matter that we craft these things out and then to be the best in the long run.
So what is the current focus in terms of that future roadmap? What are you all thinking to maybe work on and release after the next 6 to 12 months, I would say?
Right. So for RandCast, our current goal is to go after more, DApp clients to increase our requests, right? And then we also plan to roll out subscription models so that our major clients, they can enjoy a better deal. And at the same time, we also do a lot of seed investments into projects that we collaborate with. So it's more like a startup program or a incubation program. I think we can provide much more than just the product. We can also provide the community, right? So and also we can provide a lot of other know-hows in crypto market. And for zero knowledge machine learning, ARPA Network is we can expand the ARPA Network into a verifiable computation network for maybe AI agents. So there are a lot of research going on in that domain, and I find there's definitely some crossroad between AI agents and plus verifiable computation using cryptography. Even though the efficiency is still a big problem, but we are seeing some new frameworks coming out, and we are seeing zero knowledge proof as a fast developing domain. So our researchers are working very hard in that front as well.
ZK-AI, that's super interesting. I don't think I know much about some of that, that I would say vertical or that use case. But I've also been diving a lot into the AI agent stuff. I've been playing around with a couple of the different frameworks and networks. I've had a really good time with AI 16Z ELIZA and maybe building something like that of my own. But yeah, with ZK-AI, can you kind of talk a little bit more about that? Like what would be some of the use cases that you might see with an agent and that might leverage ZK in some way or another?
Sure. I feel like there are two things that we generally researching about. First one is the kind of the privacy preserving side of machine learning. For example, if we want to do facial recognition without really storing the data, right? So how do we do it using smart contract and using smart contract plus the architecture of ARPA Network, something similar to ARPA Network, right? So so that we can do inference at the same time we can preserve the privacy. I think that is one topic. The other topic is how do we verify if the tweet is really sent out by an AI agent instead of just by a person, right? So on Twitter, there are a lot of automated accounts, but these automated accounts not necessarily sent by AI.
Right. Yeah. Totally. Yeah. After running an agent, I'm starting to realize how gray the area is that you could essentially interject and take action on the agent's behalf and no one would know, right? Because it's just running it's on a server somewhere. We need verifiable AI agents.
Exactly, right? So we spend so much, we spend like so long to prove our human, to prove us the human, and now we need to do something else, like to prove that we are, the AIs are AI. So it's interesting. Yeah.
Very cool, very cool. Yeah, that's starting to become more and more interesting to me as well. That intersection of all of this stuff we've been focusing on for years in the crypto space, and then seeing it converge with AI and agents is a lot of fun. I think that's the most exciting thing that I've seen in my whole career, actually, the intersection of these individually too. So, but this has been really helpful. I have been looking at ARPA and diving in, and obviously we've been working together on some stuff. But I learned a lot, and I'm thinking a lot of other people that have been chiming in and have been watching have learned a lot as well. If someone wanted to learn more about ARPA and get involved, maybe in the community or just keep up with what's happening, can you give them some pointers on what they should do and where they should go?
Okay, sure. Let me present my screen.
Sure.
Let me see. Okay, let me see. Can you see my screen right now?
Yes, I can put you up there whenever you're ready. Just let me know.
Okay. Yeah, I think I'm ready. Right. Okay. So yeah, to know, like, basically, like, if you want to, like, we have well documented walkthrough if you want to run a node, or maybe, like, you can run node on EigenLayer as well. You can run nodes for our native staking, and we also have, like, basically you can go to docs.arpanetwork.io, and then for RandCast, it's very easy to integrate with our SDK, and I just want to show you guys. So these are like consumer contract examples. You can basically just copy. So if you want to do random number or roll dice, or pick a rarity for your NFTs or some other advanced request, you can just look at our docs and paste our code, essentially. Yeah, and also what I want to show you guys is the comparison between RandCast and Chainlink VRF. Right, Chainlink VRF is kind of the industry leader. However, we have some advantages compared to Chainlink. So we are a threshold signature network, which means there's no single point of failure. You can define what's the threshold for your random number request, and availability, faster finality, and basically higher scalability. So we believe that in the long run we can overtake Chainlink as the industry leader. And currently I believe we are the fourth. We used to be the third largest, but right now we are the fourth largest AVS by total number of stakers. We have a pretty high ETH restaked with ARPA Network, and I believe we are one of the few projects that actually start to distribute out rewards in our native token, in ARPA token, as you guys can see here. All the other AVS, they are not really distributing their own tokens, right? For EigenDA, they are distributing ETH, but for us, we are distributing our ARPA token, and we have been doing that for the past 2 months, and we plan to do it, in the future, continuously.
Very cool.
Yeah. And the last but not least, right? If you guys want to try, we have this like small demo that you can try. Just arpanetwork.io/play. You can't really find it on our website because it's kind of like a secret entry. And basically, let me just show you guys. Right. Let's see. Let's say we want to do this, right? Right, let's see. Total number 10, and then winner number, let's say just 3. Let's try it. Just wait for a moment. Yeah, here are the 3 winner numbers, and then you can check, you can verify through the base scan or these scans, this blockchain explorer.
Nice. I like the demo. I like the UI a lot.
Okay, yeah. All right, that'll be all.
Awesome. Yeah, I really like the comparison to Chainlink and the aspiration to be larger, because I think that there is competition is really good, so and it's pretty bullish that that's your goal. So that's awesome.
I'm very bullish on EigenLayer as well. Like, you guys, so before the integration with EigenLayer, we do have about 15 nodes, and they are all run by professional node service providers like RockX, Imstones, etc. However, after we integrated with EigenLayer, like all of a sudden we have hundreds of operators, right? They're all running our Docker, and then they actually did they reported a lot of bugs, and then they help us to improve our network.
Amazing.
It's like super helpful.
That's something I haven't really thought of that much, to be honest, but that's really cool. Like, as a value proposition or maybe a benefit.
Of course. Yeah.
That's awesome. Well, last thing, I guess, on that topic, if you have any thoughts or suggestions for anyone that's interested in building on EigenLayer that you've learned, because you all are very early on EigenLayer, and you probably have more context and experience than most people. Any tips or recommendations or just advice?
Yeah, I would say, if you want to decentralize your network, if you want to bootstrap your network, definitely opt into EigenLayer. I think it's a great starting place if you want to bootstrap any type of networks. And also, like, just from my interaction with these operators, they are like very professional, very helpful. I think like part of the reason is that EigenLayer is kind of subsidizing some eigen token, right, to at least like in the first couple of years to these operators, so that they are more than willing to just like hit the ground and run your to help your network. So I think that is super helpful for us. And then, like, in terms of the things that if you are a developer and you want to build, I think decentralized AI is definitely something interesting. It's growing like crazy these days. And EigenLayer can be helpful on that part, because all these nodes, they can run with some computation power.
Yeah, one thing that really is interesting to me in terms of the value prop for the intersection of AI and crypto, we talked about this a little bit already, but is the transacting part and the payments and things like that. Because, like, to me, it's always been one of the most important things relative to my 9 years experience before I got into crypto, is dealing with payment APIs. If you've ever dealt with Stripe, PayPal, all these things, Stripe's supposed to be like the easiest and the best to work with. And even with that, it's still a huge pain in the ass to deal with all this stuff. And it's typically around international payments is kind of where you end up having a lot of challenges, because you need to interop with all these different things, right? But with crypto, you just have a single line of code and you can transact from person to person. That is, that's more than like a 10x improvement, right? But how do we actually, make that UX and bring it to the traditional like applications that we use every day? That seems to have been the friction point, right? Because it's not simple to kind of onboard people into crypto and then have them be able to use it to transact, even though the transaction part is really simple. So with agents, though, if you do have some automation that's happening where a payment needs to be sent, it's very obvious how the value prop of crypto comes into play there, because you don't need to deal with all that stuff. That one line of code can actually be run and it can be used, and it does make it 10x, 50x more simple. So finding ways to kind of take advantage of that would be something to consider. Also, just keeping up with all the newest AI agent frameworks, because a lot of these frameworks do abstract away a lot of the complexity of having to actually just go and write all of this logic yourself. So for instance, Eliza, the one I mentioned before, you can set up like a Twitter bot or a Telegram bot, and you don't have to actually write the logic of, oh, I'm going to go and write a tweet and I'm going to conform to the Twitter API and I'm going to conform to all these things. It's kind of like boilerplate already built for you. So finding, okay, I'm going to combine ARPA, I'm going to combine this AI framework, I'm going to combine all these different pieces, and you can come up with a lot of really cool stuff. So I definitely recommend experimenting. So anyway, thank you so much, Felix. This has been really, really great. I enjoyed talking to you, and I'm excited to work with you all in the future. And if anyone has any questions, Felix is on Twitter. Let me go ahead and pull up his handle. It's Felix MXU. Also, ARPA is ARPA Official. Also, you can go to our YouTube. We're going to link to all of the stuff that we talked about, as well as their social handles there on our YouTube within about 24 hours. And that's about it. So, Felix, anything you want to say before we wrap it up?
Not much. Hodl to Bitcoin, I guess. Hodl to crypto. Yeah.
Cool. All right. Well, hope everyone has a good rest of your week, and we'll see you next week with another Infinite Layers.